So you can use machine learning or deep learning to do the image segmentation. As we looked at the beginning, we humans can recognize images and objects very easily. But what about those computers? Well, they can't do it unless they can't do it yet because they don't know how to do it. But by using machine learning, they can learn how to do this. Now, what is machine learning? Machine learning is part of artificial intelligence. And by the way, deep learning is part of machine learning. And as you can see from this diagram, there are traditional programs that are considered to be artificial intelligence, but not machine learning. And one way to look at the difference is to think about what goes in and what comes out from those programs. With a traditional programming, you would have put data and rules, and you will get answers out of it. And we're setting those rules. You have to explicitly, logically set the rules and code them to make a traditional programs work. But with the machine learning, you're gonna put data and answers into the machine, and the machine is gonna figure out the rules. So the thing is, we don't need to come up with the rules. We're gonna just give some example answers, like this image is an apple, this one is a monkey, this one is a banana. Then the machine is gonna figure out how to tell the difference. So let's take a look at an example. So this is a conceptual example. So let's say that we have a database of a bunch of animals, and we want a program to tell the difference between cats and dogs automatically. In traditional programming, we have to come up with explicit rules. So you might say, okay, if the animal weighs less than 10 pounds and if its tail is longer than 4 inches, I say that's a cat. And if it weighs more and the tail is shorter, that's a dog. And this is a classification problem. And just terminology-wise, the weight and tail length are called input features. And the cat and dog are the classes. So anyway, for the traditional programming, you have to come up with those rules about the input features. Now, how do we go around this same problem if we were to use machine learning? Let's make a map of the weight and tail length and pick up some data points from the database and put them on this map. And this is called training data set. And you will label them with cats and dogs. Then you will ask the machine to look at those data points and figure out a way to tell the difference between the two. And for example, the machine would say, okay, so this is the borderline between the two. If the input is on the left side, it's a cat. If it's on the right side, it's a dog. Now you have a trained machine that can tell the difference between the two. So you can throw a new data point at it and see how it performs. So what about this one? Then the machine would say, oh, it's on the left side, so it's a cat. What about this one? Oh, that's a dog. So this is just as a concept how machine learning works. Now, how does this apply to image segmentation? In image segmentation, you can have input features like the original image, and you would have classes like polymer and air, as you saw in the previous example. Then you can have multiple input features. So you can add, for example, heavily smoothed version of the original image. And this might help the machine to ignore the noise, but you also have the original so the machine can look at them both. And you set the input features like this and the classes. And what you do next is to take a slice and paint some pixels for air, because the machine is going to need some examples. And you make a couple different patches. You do the same thing for the polymer. Then you have a set of example pixels labeled as either air or polymer. Then you tell the machine, this is air, this is polymer, Now you look at this and learn how to tell the difference and segment the rest of the image. Then the machine would come back with this segmentation. So this is a pretty clean segmentation, and this happened in just one step. There is no closing operation or anything. So you can see that the machine learning works a lot easier, and it does a pretty clean segmentation in just one step. And you can, of course, do this for the entire volume. And the machine learning is not only easier way to do segmentation, but sometimes it works better than traditional thresholding.